Hello everyone. My name is Sean Pastor, and today I'm going to be reporting to you or teaching you what is geometry design, especially towards polygons and the type of polygons. So, what are polygons? So, imagine that you are walking in a road or pavement, and you see those design, those pattern, those tessellation. Those are made of polygons. For example, of that is hexagon. So I'm just going to be explaining what is the description of a polygon. So what is a polygon? So a polygon is a close two-dimensional shape with straight lines. So what is a polygon? A polygon is some shape which is a two-dimensional shape which is only a straight line segment, which is for example it's a triangle like that. Because it has a straight line segment only. If a circle is not considered to be a polygon because it has a curved line toward its circumference. So a polygon, it comes from the word from Greek, which means poly, which means many, and gonia, which is angles. So that's where it derives from. So, why are polygons so important today? As I said earlier, that polygons are used in pattern like pavement, where you can see tessellation, and you can also find that in architecture and engineering. And one of the prime examples of that is a bridge which we use trusses, which consists of triangles also to make the bridge more stronger and resilience to the forces that exist. The forces that tries to like bend it. Here is the 3D shape used in polygons. One of the examples is pyramid. I don't know where the spheres come from, but cannot be considered a polygon because it is a circle. You have bone, which is the base has a quadrilateral base, and cube is also a quadrilateral to be towards its base. So here are one of the classification of the polygons. First, we have a polygons which has 3 sides here. We also have a quadrilateral. So, quadrilateral means is that it has 4 sides and its interior angle has to be 360 degrees. One of the examples is the square, which have a equals 4 sides. And we also have something called parallelogram, which looks like this. And also a trapezoid, which looks like this. That is a trapezoid. And we also have something called a pentagon. A pentagon has 5 sides, which like this 5 sides. They can be used in buildings and architecture. And we also have hexagon, which has 6 sides. Hexagon are mostly used in nature by one of the examples of that is honeycombs from honeybees. We also have heptagon, but this heptagon are rare to find because it is found in nature because it has a 7 side which is an odd side. And we also have an octagon. This one are used in sign, which stop sign. We use that as something octagon, and also in towards our surroundings. And the last one is the decagon, which has 12 sides. And we also have a classification for that. We have a regular and irregular polygons. So regular polygons has an equal side and angles, which has an equal sides and angles. And then the irregular polygons has an unequal sides and angles. One of the examples for that is this. This is an equilateral triangle, which means it has three equal angles, which are 60 degrees, 60 degrees, 60 degrees, which sum it up into 180 degrees, and also its sides is equal, like this indicates that this equal to its sides. And we also have an irregular polygon. My example for this is the oblique triangle, which the B side is not, the interior angle does not equal to, the three interior angles are not equals, and the sides are not also equals. So that is one of the primary example of the regular polygons and the irregular polygons. And we also have a convex and concave polygons. So convex polygons, which means an example of that is a triangle. So we know that triangles are equal, the interior angle are equal to 180 degrees, right? So that is a convex polygon because its angle are exactly 180 degrees, which here. And we also have a concave polygon. So concave polygon means is that if the angle of a triangle is greater than 180 degrees, it could concave, which create a star-shaped polygon like this, like that. It would concave. And we also have a simple and complex polygon. Basically, simple and complex polygons simple polygon does not intersect itself, which means it does not intersect between its sides, while the complex polygon is intersecting. So I also have a problem for this. So how do we find the interior angle of a polygon? Well, there is a formula for that, which is like this. The S is equal to the sum of the interior angles, and the N is the number of sides of the polygon. So I'm gonna solve this. There is a problem for this. So what is the sum of the interior angles of the hexagon? So the formula for that is S is equal to 180 degrees times N minus 2. So a hexagon, how many sides does a hexagon have? It has 6 sides, right? So we plug the 6 into the equation, which is S is equal to 180 degrees 6 minus 2. So the sum of the interior angle is 6 minus 2, 4, 180 degrees, and the 180 times 4 is equal to 720. So the sum of the interior angle of the hexagon is 720 degrees. So I also have a question for you. How do we find the part of the interior angle? The only part of the interior angle of the hexagon, like this one, that angle. How do we find that? Well, we also have a formula for that, which is, if you remember, our formula is S is equal to 180 degrees times n minus 2. All we have to do with that is just divide it into its n. So after we find that, it was S is equal to 720, right? We just have to divide it by our the given side of the polygon, which is 6. So 720 divided by 6 is equal to 120. So that is the part of the one part of the interior angle of the hexagon, which is 120 degrees. Okay. What if you were given not a size of the polygon, but it's some angles. So for I'm going to give you an example. So 2,160 degrees. So let's find its side. So if you remember, the formula is x is equal to 180 degrees and minus 2. So with basic trigonometric manipulation, we could get the value of m. So s divided by 180 degrees and is 2. So we just have to plus that, then we cancel out. So n is equal to s over 180 degrees plus 2. So since we have our equation now, we could plug our degrees to that. Our angle to that. So 2,160 degrees. So n is equal to 2,160 degrees all over 180 degrees plus 2. So how much is that? 2,160 over minus 2. The side of that is equal to 14, which is a tetradecagon. Tetradecagon. So this is all for my reporting. Thank you for listening. And